Hello and welcome to another video. My name is Sam. This is the S33 Electrical channel. Today we're going to do a video that's going to be explaining what a contactor is versus a relay. So we got a lot to go over, and without wasting too much time, we'll get right into it. First we're going to go over a contactor. Now when I was starting out, it took me a little bit of time to figure this out. So by watching this video and understanding this, you'll be way ahead of the game when you actually encounter this in the field. Basically what a contactor is a square device, or sometimes a rectangle, and there's a coil. It's in the middle. It looks like a button. It actually is a button. You can press it. On the sides you'll have termination points. I usually do the line on the top, put it on the bottom. You'll want to verify this in the field, especially if you're working with one and the voltage is on. You want to make sure you're checking it out properly. And what the contactor is basically a switch that is controlled by another switch. And let me explain that. This coil, when energized, will engage and press down to where there's a connection made between the line and load side of these terminal blocks, or termination points. Okay, so this will be L1, L2, L3. You have lines coming in, you have loads going out, and this will be either going to some type of light bulb. Usually it's lighting when you're dealing with contactors. And this voltage, it's normally either a 12 volt, 120 volt, 277 volt. Those are the most common voltages you'll see. In a AC condenser, it's usually a 12 volt. It's not too critical, but this is controlled by some type of switch. This is going to be your ground neutral for the coil voltage. So this is going to be controlled either by a time clock. Could just be a standard switch, maybe a photocell. And the purpose of a contactor is so, like, if you have, say these are each 20 amp circuits, 20 amp, 20 amp, 20 amp, you can have a single switch that when it switches, it engages this coil, and simultaneously you turn on 3 20 amp circuits through this contactor. And you see this a lot in like parking lot lights, things like that. So this is what's known as a contactor, and this is basically how it works. You have your voltages, your line and load, top and bottom, and there's a coil that is controlled by a certain voltage, whether it's a time clock switch, photocell. Somewhere power is sent to here, to the coil, which engages the coil, which turns this on. So power is brought to the load side. Whenever there's no power at the coil, it's off, and then power is here, but not on the load. Okay, I think that's a pretty good explanation of the contactor. Here we have, next we have a relay. And the first thing you're going to hear about relays are the normally open and normally closed, or NO, NC. Okay, and to understand this, you're going to need to understand the basics of a circuit, which is the open and close of a circuit. So let's say you have, let's just do a simple circuit where this is your circuit, and we'll say that Okay, first, very basic, open and close. When you have an open circuit, it means that at some point it's broken. It's not completed. And when it's closed, then it would be completed. For example, right here, you can see that this is not linked, it's open. Now, if we were to close it, then it would be closed and it would be completed. The light would be turning on. So let's imagine that this is the relay. And on this relay, you're going to have a terminal block. And in that terminal block, you're going to have, it should be pretty clear with the instructions whether or not you want it to be normally open or normally closed. So here we have, let's say that it's open and it's normally open. And this is the relay on normally open. Whenever voltage is applied to the relay, it would then be closed, completing the circuit, turning on the light. So when voltage is applied on a normally open relay, then it would become closed and the light turns on. Okay, so if you have the same situation but it's normally closed, the light would be on normally. And when this voltage is applied to the relay, then it would become open and the light fixture or light would turn off. Okay, so if you're watching this right now and you're getting started in your career as an electrician and you understand this, you're going to be way ahead of the game. And on the day it comes up and you actually see this, let your journeyman explain it to you. Just kind of nod your head, and because they're not going to expect you to know this, but it's a fairly simple concept. It's just that, like all things, you got to learn it somewhere, some way. So there you go. Your relays, you're normally open, normally closed. When the voltage is not applied to the relay, that is whether it's open or closed. When the voltage is applied, then it becomes the opposite of whatever your default. If you don't get it, rewatch this video, and eventually it will make sense. I think that's it. I think we covered it pretty good. If you have any questions, comments, please let me know. And until next time, peace.